So we are here to talk about GenAI reliability, agentic reliability, right? And before we can get started, quick introduction about myself. My name is Vikash Rungta, and I just came out of Meta like a month ago to build my own company. But before that, what I was doing, I was on the LLaMA team working on the safety and human alignment piece of it, which is what it means is how do we get this foundation model to kind of really align with the human values? And how do you get them to kind of do that reliably is super important, because there could be problems like we were just talking to somebody about what if my models are just too agreeable to me? That's not reliable, because that's not the kind of thing that we are looking at. What if it's too preachy? That's not the kind of thing that we are looking at either. I also teach at Stanford continuing product with GenAI for product managers, so check it out if you're interested in that. With that, if you need the slides, you can take the picture. I don't know if they're going to post it or not, but take a quick picture of that, and happy to kind of like just get the slides along. Cool. All right, so, with GenAI, we are in Silicon Valley. We all have so many ideas, right? Like, there's so many things that we want to build, and now it's all possible because of vibe coding and everything else. And what it takes to kind of build a GenAI product today is we ideate, and we build something quickly, either using vibe coding or even putting together a RAG-based system or an agentic-based system is not that tough. There are products like Crew AI. Juan was just here, I just met him. Those things are so easy to kind of build that it's easier for us to kind of build. So idea to production is no more a big challenge. What you do is you attach a vector database, you connect your models, and you write some system prompt, and we have a system or an agent that you're ready to kind of ship. But once you ship it, right, how do you kind of go about evaluating it? And generally, if the models, what you shouldn't be evaluating is the output for the model itself, but your job of a product or anything that you're ideating is really what can the product do for the user, right? It's not about if the product is generating amazing output or not. It's about what is it doing for the user. And if a single chatbot is very different for a doctor versus like if you're building a song lyrics, like it has to generate something completely different. So what it means is that even if the models perform the same way, it shouldn't actually be doing the same thing if you're based on your idea or the product itself, right? So number one is like don't ship a model. What you should really be shipping is an experience. And you have to kind of think deeply about what is the experience that you want your users to have, right? In this particular case, an experience, because a lot of times you are shipping the chat models, your experience is actually defined by the responses that you provide. But is it the first response that you provide once you ask a question? Like if I'm going to a travel website and asking for an itinerary, is it most important to have the first response, which is nice and like agreeable? Or is it much better for me to kind of have something that actually builds and helps me travel or build an itinerary that I really care about, right? So if you think more about the experiences, it will understand that we cannot just measure single turn outputs or immediate value, right? So how do you kind of go about measuring success? I think there are 3 R's that you should kind of follow. Number one is the reality check. If your output is not factually correct, if you're asking for a trip to Paris, and if it is suggesting Golden Gate Bridge, that's not reality, right? It can confidently do that, and we see that all the time. That kind of hallucination happens all the time, right? So you have to make sure that your outputs are real. Is it relevant? Is it something that I want as a user or a user of the product? If I am suggesting if I'm asking for a 7-day trip to Paris, then is it relevant in the way, is it assuming that I'm a tourist? Is it understanding the way I kind of like want to travel? If I'm on a business trip, my output should be completely different versus like if I'm on a personal trip or if I'm going with kids versus not kids. So if the outputs are not relevant, it doesn't matter how nicely formatted it is or if it is the best itinerary that it can provide. That's exactly what the trip advisors of the world are doing today, is like they are able to provide one common itinerary for everybody. It's like, doesn't matter what you're there for, here's a 7-day itinerary. And that does not work. And lastly, you have to think about the results, right? What good is an evaluation if it does not let you, if you don't take that trip? If you don't take that trip because of the recommendations that you have made, it doesn't matter how nicely you have presented or how good, how factual it was. So make sure that you have a way of kind of measuring the success for the users as well as the success for the business. What if that results, that trip, if I'm working for Expedia, and if that trip does not result in like somebody booking a trip with us, then we haven't received the business goal. So look for what are the users' goals that you want to have, and what is the business goal. Right? With this 3R, now you're ready to kind of at least know that your system does what it's supposed to do. Right? But wait, I think this whole conference is about evals, and I think you guys are hearing about it all day. But maybe the good evals are not what reliability is all about, right? Maybe this car runs completely fine, right? It can accelerate the right way, it has the seat belts work and everything else. But is this something that you may be wanting to kind of go in? If your Waymo showed up like this, right? Actually, it may be kind of cool. But if your Waymo showed up like this, would you kind of go in? And what reliability really means is that over time, do people trust your product enough to rely for their critical business needs, right? It could be a personal business need, or a business need that you're kind of building for. So what it means is that when you're evaluating an agentic system, a lot of us spend a lot of time on like the individual agents or the verification, where if you have a multiple agent system, what we do is we run evals for each of the agents individually, which is like, is agent A working properly? Is agent B working properly? However, where a lot of the people are not spending time, at least from my conversations, is they're not looking at the system level thinking. They're not looking at system level validation. It's like, as a system, does it work? And more than that, even if you validate some of the system level aspect, does it build end-to-end trust? It only takes one wrong response, where it only takes one golden gate in the response, and you stop like in a trip to Paris, where you stop kind of thinking about what is useful and can I trust this system or not. Let's take a quick example of this. So I want to bring home like how things are changing and like what's happening. Let's imagine a perfect day where Acme Corporation is building a multi-agent system called Helix, right? The job of the Helix is to kind of design to bring competitive landscape information from various sources and provide a summary to the leadership. It seems pretty simple. Like you look at multiple sources of what's going on. Every day, 8 o'clock in the morning, you receive all the information as a summary. And to build that, they build 4 stages of agents, right? The first one is the retriever, which kind of goes ahead and retrieves all the content, like all the information that you need to kind of actually build that intelligence. The second one is the summarizer. The retriever will pass it on to the summarizer, which says like, hey, can you summarize this, all of this information that we have, which may be multiple pages each or could be large documents. And once the summary has been created, you give it to a formatter agent, which is formats in a way which is consumable for the person who's using it. And then ultimately there is a delivery agent which kind of figures out if you should email them, Slack them, or whatever else it is. Seems pretty straightforward. I think it's a very simple multi-agentic system. But this happened at 2 o'clock at night, right? One of your vector databases actually partially crashes, where 30% of the documents were silently missing. Why? Because maybe one of the nodes came down. Remember, most of us are, while we are building the agents, we are actually most likely broadly thinking about agents overall, and systems never go back, especially in the hello world when you're using Crew AI or anything else, like any of the agent builders, you're not thinking about these failures at all. And here's the bad part about the failure. Like, what happens in a case like this when it fails? The response from the vector database to the retriever actually happened partially. So what it means is that the agent has received some information, and good or bad, if either you're doing RAG or agentic RAG in both cases, your prompt will include, a system prompt will typically include like the main system prompt and a lot of context, which says that I want you to kind of retrieve all of this information, and here are the 10 documents that we have. If instead of 10 documents, if you gave them only 7, the models don't fail, right? They just keep going. And in a historical system, if something like this happened, you would get a 500 error, like HTTP 500 as an error code. In this case, you get a 200 with a limited set of information. And from there, it just kind of populates over, because now the summarizer actually does not know if the retriever has completely retrieved the documents or not. It has no awareness of the vector databases, and so on and so on. And formatter nicely formats and sends it out, right? So what happened here is a simple vector database skipped at a time a small amount of context. The retriever neglects the fact that it didn't get the whole thing. Actually, even with MCP and others, so this could either be a RAG implementation where we have taken the data and you're posting the prompt. Models don't care, or agent will not care because you have received it. If it's an agentic RAG where the agent actually goes out and retrieves it, if an MCP does not respond, it just keeps going on because it knows that its objective is to complete the task, and it will keep going on. And so once the retriever has neglected it, the summarizer just goes ahead and kind of summarizes the whole thing anyways. The formatter, being the confident like the LLMs are, actually very confidently sends out the update saying that your updates are ready, and the delivery, of course, doesn't care about it, right? So what we have is like just a failure which would result in a failure of the overall system. So how should we fix this? I think this is the reliability playbook that I think about, right? You need to start thinking about context as a contract. So whenever there are contexts available for a model, it should be able to kind of challenge and see if this context is complete or not. So you have to start building, in this case, the retriever agent. All right, let me go back the other way. So the retriever agent should have a way to kind of validate that it has all the context or not, especially if these contexts are important for you. Or there should be a contract between retriever and the summarizer, where the summarizer is able to kind of validate that, hey, can you confirm that all of the context has been given or provided here or not, right? You must build some kind of a contract, and it's going to be more of a system engineering rather than agent. And this is something A2A and others should start to kind of look at it as well, right? You should start to build semantic canaries. What it means is that you should start to regress your models and see if you can actually introduce some of these failures in the system, and are you able to kind of regress this? If what happens is when you start to regress these things, you should be able to see that these failures are actually being captured, or if it is not captured, is there a way for you to kind of improve on this, right? Measure what matters, right? Ultimately, you have to figure out with the failure or without the failure. In case of the trip example to the Paris, was this a trip that person has actually taken? So you still want to see if with all the failures, are you still able to build a system which is reliable enough? Because reliability can potentially never be 100%. It's okay to live with certain amount of reliability. And you want to continuously measure that. Is it hurting where it matters the most? It's okay maybe if you are retrieving, for example, the name of the person where the delivery has to be made, and an email went out without saying that, hey, Vikash, here is your summary today. It is not something that is hurting you. And this is how you should prioritize reliability. You prioritize reliability where it matters the most, because you will have places where it will fail. And lastly, what I would say is don't fail softly. This is one of the biggest challenges this year. There has been a lot of reports around this as well, is a lot of the systems are failing softly. What it means is that when you start to kind of talk to another agent, a vector DB or someone else, we are all getting back 200s without the information. What if an LLM is supposed to generate 5,000 tokens and it hits a token limit and generates only 2,000 of them, right? So one of the models agents can send 2,000 tokens while it knew that it has to send 5,000. It ran out of the billing. Yeah, you are out of token counts. So there are so many different things can happen. And if this happens, how do you actually kind of like build out a system that can fail loudly so that somebody can look at it over time, right? In summary, what I would say is like start thinking about building the context contract, right? Like what does that look like? Start thinking about the semantic checks, like can you build regression? Are you able to kind of check on different points? Because some of this is not going to be easy. For example, in case where you run out of cash on your account and the tokens are not generated because you don't have money, you may have to build API access all the way to OpenAI or whoever else that you're using to get their billing information and see if there is an error that they have generated. Or does the API provide that information? Right? So thinking about a system which initially we could build very easily, now it starts to become complicated. Of course, run your evaluations to kind of see it is valuable, and monitor your system. So we recommend, like highly recommend putting more observability. Of course, there is an observability that Arise and Phoenix kind of place provide, but there is also observability all the way down to the GPU that you have to kind of think about. Like, what can you observe to know when systems fail and what they have? And just know that failures is a thing that's going to happen. We're not going to reach 100% reliability on anything. So the most important part is, are you able to heal as soon as possible when a failure happens? Are you able to kind of learn about that? Because knowing about the failures and not healing is the thing where people don't trust you. And this is exactly what I am also building. This is my new company, Alloy. Right? What we are building is a quick plug here. Is we are building this continuous monitoring, self-failure detection, and self-healing mechanism, right? So that we can plug into your entire system, really read information about different aspects of it, and bring that information all the way from the GPU to the prompts, so that we can identify and root cause what's going on, and ultimately auto-remediate that, right? So it's a teammate that you can work with. That's all I have. Happy to take questions.
Any questions from anyone in the audience? I can hand over the mic to.
Can you elaborate a bit more on failing loudly? So what do you mean by that, and the implications of that failing loudly?
Yeah. So let's go back to the example where a lot of the failures are happening with the 200 HTTP code, where machines return, but they don't return the right type of data. Sometimes you may ask a question to the prompt, like, plan me a trip for 7 days in Paris, and the response may come back, I think there might be other cities. Are you talking about Paris in France or somewhere else? And you may actually take that information and process the rest of the models can actually process that. In this particular case, you want to detect and figure out what does it mean to kind of like, instead of softly failing, or is there a way to loudly fail? In this case, I would actually put systems around it. Is like, if a give system prompt that if you have any questions, you must not ask or like continue to provide a response, or call this other system which says that, hey, I don't have enough information to generate, and generate an error. So your model can be prompted to call another MCP server, which says that generate an error that the prompt given was not enough. So instead of just responding with whatever you could, your models have to kind of learn. Same thing around like building up for vector databases and like a lot of other things, LLMs, any of your GPUs and everything else. If some failures are happening somewhere, raise it up, bring it up, instrument it up, and kind of like bring it up for reliability. Great question. Yeah, go ahead.
Yeah, thank you for the presentation. I would like to ask one question. So you are talking about the context validation, right? And you mentioned context contract. Yeah. What do you mean by context contract? Like, how do you actually validate the context? Because from my understanding, context is basically, for example, if I store it in the vector database, right? I assume that it's always returns a correct result. Like, let's say as you said, like 30% just gone, probably because of somebody hacked into the database, let's say. How do I know? Because I always assume the return result is correct, right? How do I know? How do you validate it?
Yeah, no, it's a great question. Look, when you are missing the context, number one, if it's agent-to-agent communication, and you have to kind of like provide the context, let the second agent know that, make sure that your prompts has the name of the person that you are trying to send. And it has the information about like what summaries that they need. And it has the information about all the documents. And it also should provide the number of documents that you're providing, for example, right? So by asking the models to expect when between two models, so that if any missing inputs are there, it must look for it or raise an alarm through the mechanism that I just talked about, is like somehow say that there is not enough context being provided. And you can decide if it is enough or not, right? You may raise a warning or, yeah. Agent, so I'm covering the agent to agent, and then I'll come to vector DB as well, right? So between the two agents, so any agents must know that what is the amount of information that is there. The second thing is when it comes to like vector databases and others, is there a way for you to kind of confirm how many types of context that you actually wanted to provide? So maybe have another table which says what is the number of context that we have. So it has to be system engineered, and it has to be specific around like what does it mean to have or not. In this particular case, you should be monitoring the vector databases like some kind of a failure happening as well, and say, oh, if there is a read failure for parts of it, we should raise an error and give a 500 rather than a 200. That's number one. Or you can count the number of contexts that is available that can be brought in. Yeah, it's not straightforward, but I think that is something that you have to kind of build as a system engineering.
I think we had a question over here.
Thanks a lot. Thank you so much. So agent reliability is still like relatively new topic for me. So thank you so much for sharing. So question really easy for beginners. Which like metrics would be relatively effective or most critical in this field?
Yeah. So what I would say is two metrics. One is measure what matters. Like that should be the eval, and that should be for eval everything. Like whatever system that you're building, if the response is not something that is letting them complete the trip to Paris, or they're not booking, you have failed in some ways. And it's okay to say, we have 10% completion rate or 20% completion rate. As a product, that should be the North Star. As an engineer or somebody who's kind of responsible for the system, I want to see what percentage of times the models or the outputs were generated as expected. Currently, we are looking at each individual components and measuring that. So I want to see the uptime of the quality of response. So move from a soft failure to a hard failure, or count the soft failure as well and say how many times we are having a soft failure, we're running out of tokens. The length was less than I expected. If the summarization, always expect 500 words. Like see that there are 500 tokens. If not, start to do things like drift analysis, which I think Phoenix also has, could be a great one as well. Like over time, are you seeing certain number of prompts coming out of that? So those can be the couple of metrics. Great question.
These are great questions.
Yeah.
You got room for one more, maybe?
I can, yeah.
Okay.
Hi, my name is Josh. Thanks for taking the question. Real quick, what's your thought process on how you manage cost of tokens of testing?
Cost of tokens for?
So testing? Like, I'm assuming that it takes, it costs tokens to run tests, to create tests, to test the data sets, for example.
Yeah, so it should really be driven by business logic. If your business demands higher reliability, for example, my friend over here is with Deutsche Telekom, right? Like, and if they have very high standards of a telecom provider how much they can afford. So if you can afford failures, it's okay. If you cannot afford failures, you need to kind of like upgrade the systems. And what happens is if your system is not reliable and if your users start to kind of like understand that, they may just kind of phase out. So drive people's expectation of reliability, right? You should know, ChatGPT says clearly like the answers may be hallucinating, I don't know the exact term, but it says that. So a lot of times you can build reliability by two factors, by the way. Reliability is all about trust. You can either make your system reliable or change people's expectation of reliability. And it's like, if it's something that they can expect failure, they will be okay, they will try again.